all, welcome to homeschool. Hope everybody are doing good. And we are with the chapter class 11 chemistry, hydrocarbons. In my previous video, I discussed everything about chemical properties of alkenes. I mean, not all the chemical properties. I completed Marconi-Kauss rule, anti-Marconi-Kauss rule, addition of water, addition of hydrogen, addition of halogens and all that, right? Coming to today's video, this is going to be the most amazing video, trust me, because I'm going to talk about the super trick on ozonolysis and the reaction of alkenes with KMnO₄. So usually students feel difficult with this particular reaction, that is alkenes reacting with KMnO₄. So we are learning oxidation of alkenes, okay, in presence of KMnO₄ reagent. See, dilute KMnO₄ reacts differently. Concentrated and hot KMnO₄ reacts differently. So first let us understand how alkenes react with cold and dilute KMnO₄. Usually cold and dilute KMnO₄ is called with the name Baeyer's reagent. Baeyer's reagent. So that's why even this reaction is called as Baeyer's test. I'll tell you why this test is very, very important little later. Fine, let's see how actually reaction takes place. See, whenever alkene oxidized, in presence of cold and dilute KMnO₄, you will get diols. So what do you mean by diols? Two OH group containing organic substances you will get. Okay, so if two OH groups are present on adjacent carbon, you will get diol. We generally call them as vicinal diols. Okay, if two OHs are present on adjacent carbon, then we will call it as vicinal diols. So vicinal diols you are going to get. So let's understand this with one example. Suppose I have CH2 double bond CH2. I treated with cold and dilute KMnO₄. Okay, so in presence of water, this reaction, yeah, of course, dilute KMnO₄ is there, so water also you will observe. Fine. Say here what actually happens is two OH groups are produced. One OH group is added to one carbon atom, another OH group is added to another carbon atom. Just like the way you add hydrogen atoms, isn't it? So that way OH groups are added to unsaturated carbon atoms. One OH to one carbon, another OH to another carbon. So what you will observe is double bond will become single bond. So you will get a compound CH2OH, single bond CH2OH. Okay, so two OHs on adjacent carbon. So how do you name it as? This can be written as ethe 1,2 diol, isn't it? So this type of diols you will get. Fine. So now actually cold and dilute KMnO₄, it is in violet color. So during the reaction, the violet color of cold and dilute KMnO₄ will disappear, right? So since reaction is happening, the cold and dilute KMnO₄'s color disappears. So due to this color change, one can identify that reaction is happening and reaction is happening with alkene. So to some extent, this reaction can be used as test for unsaturation. If you want to identify whether the hydrocarbon is saturated or unsaturated, you can go for Baeyer's reagent. If it is unsaturated, only this kind of addition of OH groups takes place. Okay, that too in presence of this reagent. If it is saturated hydrocarbon, there is no addition of OH groups on carbon atom. Okay, so if reaction happens, violet color of KMnO₄ disappears. So that is the reason this can be used as a test for detecting alkenes, especially unsaturated hydrocarbons. That is the reason used as a test for unsaturation. So it's very, very important to remember Baeyer's reagent test. Okay, fine. So we have seen how our cold and dilute KMnO₄ reacted with alkenes, right? So I'll end this concept with one question. You can try this question and post the answer in a comment section. Suppose I have a alkene CH3CH double bond CH2. So I will treat it with cold and dilute, KMnO₄. Try to write the product. Okay, so write the name of a product and post the answer in a comment section. Don't forget. Fine. And now let me talk about reaction with hot and concentrated KMnO₄. Okay, extensive oxidation takes place here. So here I am giving you super trick. Try to remember, guys. See, if you have a group double bond CH2 in any alkene, if you have CH2 group with double bond, on treating with hot and concentrated KMnO₄, this CH2 group with double bond, whatever is there, no, that is getting converted into, it will always gets converted into CO2 plus H2O. Okay, so this group always gets converted into CO2 plus H2O. Fine. Suppose if you have this group in alkene, okay, CH with double bond. This group on treating with hot and concentrated KMnO₄, this gets converted into COOH group, guys. Okay, so this CH group gets converted into COOH. Suppose you have just double bond C. Okay, so some carbon, you don't have any hydrogen with it, you have double bond around it, then this carbon in presence of hot and concentrated KMnO₄ gets converted into ketonic group. Okay, so this is what the major idea you should remember. Suppose you have CH2 with double bond, the entire piece gets converted into carbon dioxide and water. You have this piece in alkene, then this fellow gets converted into COOH. If you have this type of carbon in a alkene, double bond, where you don't have any hydrogen atoms for this fellow, then this carbon gets converted into ketonic group. Okay, so now let us try to write the product for few questions. Predicting product is very, very important here. Okay, so in the competitive examinations, they'll ask you what is the correct product. Okay, so they give reactant, they'll mention the reagent and they'll ask you the product. You will have to be very, very careful. If you can understand such tricks, it's very easy to write the products. Coming to first example, suppose I have CH2 double bond CH2 and I am treating with hot and concentrated KMnO₄ solution. Can you able to predict the product? See, across a double bond, you just check the pieces, check the groups. See, this is CH2 with double bond, just of this pattern. And what about the other group? This is also CH2 with double bond, this pattern. So one fellow, one piece gets converted into CO2 plus H2O. The other piece, the other one is also CH2 with double bond, this pattern, right? So this fellow gets converted, also gets converted into CO2 plus H2O. So altogether you will get 2 molecules of CO2 and 2 molecules of water. Okay, so when ethene undergoes reaction with hot and concentrated KMnO₄, you get 2 molecules of CO2, 2 molecules of water. Right? So let me go for the second example. Suppose you have CH3, CH double bond CH2. So I will treat it with hot and concentrated KMnO₄. So what may be the products you will get? See, just check wherever double bond is there, just try to break it. Say this is which one? CH2 with double bond. It's like resembles this piece, right? So this entire piece gets converted into CO2 plus H2O. So this is one product. What about this fellow, this carbon you see, CH double bond, it is of this pattern, CH double bond. So this guy, this carbon gets converted into COOH. So this CH3 remains same guys, nothing will happen to this CH3, only this part, this carbon gets converted into COOH. So you get acetic acid as one of the product here. Okay, so that is how you can apply the trick for various questions. And let me take the third example, CH3, CH3, CH3. Suppose if this is an alkene you have, and they mentioned hot and concentrated KMnO₄, right? So what may be the product you can expect? So just break wherever double bond is there and then guess. What about this fellow? You see, this resembles this, right? So carbon, just carbon, this particular fellow, this carbon do not have any hydrogen, but it has double bond. No hydrogen with double bond, then this and this carbon gets converted into ketone group. So these two CH3s will remain as it is. So one product is CH3 double bond. So acetone you will get as one product. The other one CH double bond. So this entire thing getting converted into COOH, right? And this CH3 stays as it is. So CH3 COOH, it's called as acetic acid. So one molecule of ketone, one molecule of acetic acid you will get. Okay, so try to remember these three examples, very, very important. If you can remember this trick, you can write products for any alkene. Okay, so this way cold and dilute KMnO₄ reacts with alkene, it gives you diols. Hot and concentrated KMnO₄ on reaction with alkene, you may, depending on the carbon, if you have this type of a carbon, you get carbon dioxide water. If you have this type of a carbon, you know, you get COOH. If you have this type of a carbon, this type, you get ketone. Okay, so this is all about the reaction with KMnO₄. Now let's go for ozonolysis, the most important reaction, that is reaction with ozone in presence of zinc water. See here, whenever an alkene reacts with ozone formula is O3, you initially get an intermediate called ozonoid intermediate. Ozonoid intermediate. See, first let me explain you the mechanism, then I will go for the trick. Okay, so both I will explain for you all, so that you will come to know the concept and also you can apply a trick for writing the products. Clear? See, alkene on reaction with ozone, initially you will get ozonoid intermediate. Later, this ozonoid intermediate will break down. It's very much unstable. Easily you can break it with the help of zinc water. Okay, so here actually you are doing a reduction. So here zinc water will act as a reducing agent. On reduction, you will get your final products. Depending on the alkene, you can either get aldehyde or ketones as the final products. Clear? So let's understand with one particular example. Let me take an alkene as CH3, CH double bond, CH2. So this is propene. And I am initially treating with ozone. So you have to write ozonoid intermediate, right? So this CH3 will remain as it is. So this is CH. See, double bond will break down because ozone atoms, three oxygen atoms are getting added to double bond. See how they are getting added. Double bond, when something is added, that double bond will become single bond, isn't it? But here three oxygen atoms are added, so you don't have any bond in between this carbon and this carbon. So just I'm not showing any bond, right? So this is CH and this is CH2, right? Fine. And now you see how the three oxygens are added. One oxygen here, the other oxygen here, and there is a connection. And the third oxygen somewhere like this. So this is what we call ozonoid intermediate. So this is highly unstable, guys. So what happens in the next step is, in presence of zinc water, these bonds will break down. See how the bonds are getting broken. This bond will move here, okay? This bond will move here and this bond will come on to oxygen. So oxygen, one oxygen is coming out with zinc, okay, right? So when this bond moved on to here, you get a double bond here, right? See, let me write about this piece, right? So what are you getting? CH2 double bond O plus this piece, you see, this piece. What is that? CH3, this single bond, CH, and you have a double bond, right? So what is this? This is an aldehyde, acetaldehyde, right? So this is acetaldehyde, and this is formaldehyde. So two molecules of aldehydes you had got, right? So this is what the mechanism of ozonolysis. Initially you get a ozonoid ring and then ozonoid ring breaks up, you get aldehyde. Say in the examination, they'll be asking you to predict the product. So they give some alkene, right? Say suppose CH2 double bond CH2. So above the arrow mark ozone, below the arrow mark zinc water. So ozonolysis is happening here. You have to write the final product. I mean what aldehyde or what ketone you are getting. That you have to show it as a product. No need of showing a mechanism. And it's very difficult to go for a mechanism and then predict the product. Sometimes you feel it difficult, right? So for that, I will tell you super trick. Clear? So the trick is, listen carefully. Wherever double bond is there, you break it. Okay? Wherever double bond is there, you completely break. One oxygen you add to one carbon, the other oxygen you add to other carbon. So what is this piece? What is this piece? You will write that as CH2O. So what is this? You have completely broken, right? CH2O. So these are your products. CH2O in the sense what? HCHO. So what is CH2O? It is HCHO. So two molecules of formaldehyde you are getting. Okay. So simple. Wherever double bond is there, you break it. One oxygen you add to one carbon. The other oxygen you add to another carbon. That's it. And you show them as a product. I take the same molecule. CH3, CH double bond CH2. Okay. So suppose I have ozone above the arrow mark, zinc water below the arrow mark. So what happens? No need of going for this mechanism and then writing a product. See, double bond is here. I'm breaking it. So one oxygen I will add to this fellow. The other oxygen I will add to this fellow. So wherever double bond is there, you are breaking it, and for those carbon which had connected to double bonds, no, for those carbon you are adding oxygen on either side, for both carbons. That's it. So what is this piece? You will get as CH3 CHO plus what is this? You will get CH2O. So acetaldehyde and formaldehyde. Acetaldehyde, formaldehyde. That's what you had got. Okay. So now suppose if I have CH3 double bond, okay, CH3, and I am treating with ozone in zinc water. Okay. So can you all predict the products? Observe here. Double bond is here. I'm breaking it. So for this fellow, I'm adding one oxygen. For this carbon, I'm adding another oxygen. So what is the product? So what is this piece? You will get as CH3C. This CH3 is as it is. So oxygen to this carbon. Always oxygen is connected with a double bond to a carbon, right? So what is this? Acetone. So this is acetone you had got. So which is another product? Another product is, you see, this CH3 is as it is, right? CHO. You got acetaldehyde as another product. Isn't it? So simple. So tell me, how did you feel about the trick, right? And I'll give you some questions. Try to work it out. See here, I'll be giving you few questions. CH3, CH3 double bond CH2O, ozone, zinc water. What is the product? The other one, CH3, CH double bond CH double bond CH2. Ozonolysis with zinc water. Tell me what are the products. So this is question 1 and this is question 2. See here, two double bonds are there. No, both bonds will break down. This bond also will break. This bond also will break. For this oxygen, for this carbon, one oxygen. 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 So carefully try to write the product and post the formulas of a product or names of the product in the comment section. Okay, so that's all about the trick. So I repeat once again, wherever double bond is there you break down, add oxygen atoms to both carbons and show it as a product. Okay, so depending on the alkene, you will get aldehyde or sometimes ketone. This is all about ozonolysis. Nothing much to worry about it. Okay, that's all about today's video, guys. With this, I have completed alkenes. So in my next coming videos, I may start up with alkynes. Okay, and also aromatic hydrocarbons. So do subscribe our channel to learn the concepts in the easiest way. And don't forget to share the videos with your friends and do like our videos if you like all these tricks. Thank you so much. All the best. Keep learning.